Okay, so for the first part of the tutorial, we have the beginner questions. So this is just a review of Python syntax, variables, input and output. Okay, so very basic things. Okay, so 1.1, a farmer has asked you to write a program to calculate the perimeter and area of a rectangular plot of land. Okay, so the program should ask the user for the length and width of the rectangle and then print out the perimeter and the area. Okay, so we know that we should have the length and the width as inputs. Now remember what we went through last time. The input function returns a string. So if we're dealing with distances like length and width, we need to convert that into a float. Okay, so let's have a look here. Okay, so we've got the start of the solution here. So width is equal to float, and then input, and then width. So we use the input function to ask the user for input. Okay, but we know that the input function returns a string. So this inside part will return a string. We need this outer function float to convert the string into a float. Yeah, and then we just save that in the width variable. Very similar for the length. The input function inside will return a string that will then be passed into the float function, which will convert it into a float. Okay, so it's very important that we're working with floats. Okay, so the area that can be calculated as width times height. So remember the star character here, that is for the multiplication. If we want the perimeter, we can work it out as perimeter is going to be twice the width plus twice the height. So 2 times width plus 2 times height, okay, since it's a rectangle. And then we can just say 2 times width, 2 times height. Here we're using an integer 2 and a float width. Okay, but remember Python does auto conversions. So if we have an integer times a float, that will give us back a float. Okay, so perimeter will be a float as well. And then we can just print perimeter equals, and then remember if we have a comma separated parameters here, then this first part will be printed. Then if there's a comma, it will print a space. And then we have area, which will then be printed afterwards. Yeah, and then we can do the same thing for perimeter. Okay, any questions on this first part? No. Okay, so basic input and output. Okay, let's have a look at something a bit more difficult. Okay, so the medium level questions. So write a program that asks the user for a positive integer. If the number is prime, then the program should output prime. If the number is not prime, then it should output composite. Okay, so you have prime numbers and you have composite numbers. And then a list of its factors. Okay, so let's have a look at that one. Sorry, that was... Okay. So how can we determine the factors of a number? So first, we ask the user for the number, so input number, and then we want to work with integers because integers can be prime or composite. So we use the type converting function int to convert the string into an integer. Then the question asked us to list the factors, so we create an empty list of the possible factors. So create an empty list of the possible factors. Okay, so we start out with it being empty, and then as we find a factor, we can then add it to the list. Okay, so how do we find the factors? Well, we can use a for loop to go through all the possible numbers from 1 up to the number. Okay, so that's what we have here. We have a range-based for loop. So this range starts from 1. Okay, so that's the first factor that could go into a number and ends at num inclusive. Okay, so remember with the range function, this upper bound or ending over here, this is not included. So if the range just ended at num instead of num plus 1, then that would not be included. However, we do want to include the number because the number is a factor of itself. Okay, so we need to put num plus 1 so that we include the number as well. Okay, how do we check if a particular number is a factor or not? Well, we can use the modulus. Okay, so if this number n divides our number, then it is a factor. So if the remainder after division is 0, then the number is divisible by n. So that was n inside our for loop. And so n is a factor. So since it's a factor, we can add it to our factors list. Remember, we use the dot append function to add to the list. Okay, so we use the dot append function to add to the end of the list. Okay, so we have a list of all the possible factors of the number. So now that we have this list, how do we determine if the number is prime or not? Well, if there are only 2 factors in the list, then we know that the number is prime. Because we can say if the only elements in the list are 1 and the number itself, then the number is prime. Okay, so we know that from working with prime numbers. Okay, so it only has 1 and itself as factors. That means it's prime. So if the length of factors is 2, so we use this len function to determine how many elements are in the list. So let's just make a note here. The len function, this is short for length, gives us the number of elements in the list. Okay, so that is a useful function that we'll be using. So if the number of elements is 2, that being 1 and itself, then it's prime, so we can print prime. Else, so if this condition fails, then we go here, print composite, and then if we just print out factors, then it will print out the list. Okay, so the print function takes the list and makes it human readable for us to print out. Okay, any questions on this one? Okay, cool. Let's have a look at the next one. Okay, 2.2. Write a Python program that asks the user for a comma-separated list of numbers as an input string. The program should then return the minimum, maximum, and the average of the list. Okay, so here we are asking for multiple inputs, but all the inputs should be inputted at once, okay, using a comma-separated list. Okay, so there's quite a bit to do for this one. So let's have a look at the solution. Okay, so the first thing that we need to do is ask the user for the list. So we have here number list, and then I put underscore str just to say that it is a string. Okay, so it's clear what we mean there. Is equal to input list. So that's fine. We don't need to do any typecasting because the input is a string. We want it as a string, so that's fine. Now we want to convert this string into a list of numbers. So here we use the list comprehension. Okay, so I briefly went over this in the first lecture. So this is a list comprehension. Okay, so what are we going to do? So let's just go through the generating parts with this for loop. So what we do is we go through each number in number.list, number list string, so that's the string that we've entered, dot split, and then we've provided a comma. So what does that do? So the string method dot split will split the string based on the input character. So here we want to split it on a comma, which means we get a list back of all the elements split where there's a comma. So as an example, if the string is A, comma B, comma C, comma D, for example, if that's our string, then if we split it on a comma, like we have here, then the result will be a list of A, B, C, and D. Okay, so we get a list back with the string being split up from the comma there. Okay, however, the split method will return strings. Okay, because you've got a string, you split it, and you get back substrings. So what we need to do is convert the string number into a float number. And we can use the float typecasting. Okay, because this number inside here is a string from the split method. We use a float and we convert it into a number, which means that this entire list here will then be a list of floats, which is what we wanted. Okay, so we will be using this quite a bit when we do data handling from files. So we will read in the comma-separated data as a string. We will split it into its individual parts and then typecast it as we need. Okay, so now we need to find the maximum, minimum, and average of this list. Okay, so the NumPy module has special methods to find maximum, minimum, and average. Okay, you can use those if you want, but this is the longer way to do it, just to give you a better insight on what's happening behind the scenes. Okay, so how do we do that? Well, first we set the minimum and maximum to the first element in the list. So remember, index 0, that means the first element. So we set the minimum and maximum to be the first elements. Okay, so there's no particular reason why we choose the first one. It's just out of convenience. Yeah, it's just like our first guess at what the minimum and maximum could be. Okay, and average is set to 0. We're going to be adding on to the average and then dividing by the total, and then that gives us the average. Okay, so how do we find minimum and maximum? Well, we can go through each element of the list. So we use a for loop for that. So we go through, or we iterate through all the elements of the number list. Okay, as we go through each element in the number list, if the number is bigger than whatever we set the maximum to be, then we replace the maximum with that current number. So if the current number is larger than the current maximum, then we replace the current maximum with that number. Okay, so that allows us to continually update the maximum as we go through all of the elements. And we can do the same thing for the minimum. If the current number is less than the minimum, then we replace the minimum with that current number. So we can just copy and paste the statement here. So if the current number is smaller than the current minimum, because we want the smallest, then we replace the current minimum with that number. Okay, so again, it's continually updating the minimum if we come across something that's smaller. And then the average, we can just add the number. Because remember, for the average, we just sum everything up and divide by how many elements there are. And we do that over here. So first we can print out the maximum. Okay, then, the minimum. Then we can print out the maximum. Okay, and then for the average, we take the average here, which is just the sum of everything. Okay, so here average is the sum of all the elements divided by the length of the list. And remember, length, LEN, length of the list, that is the number of elements. So we're taking the sum, dividing by the number of elements, that gives us the average. So the sum of all the elements divided by the number of elements is the average. Okay. Any questions on this one? Okay, so not too bad. Okay, awesome. Let's take a look at the last one here for the medium questions. So a perfect number, okay, so that's just a type of number. So a number can be prime, it can be even, it can be odd. We can also have perfect numbers. So a perfect number is a number whose factors, including 1, sum up to that number. Okay, for example, if we had 6, we have 1 plus 2 plus 3. We don't include 6. Okay, because of course, if we included the number, then the sum would be greater than that number always. Okay, so we don't include the number itself. Okay, so again, for 6, we have 1, 2, and 3. We add them up and we check if it's the same as the number. If it is, then it's perfect. If it's not, then it is not perfect. Okay, so write a function called perfect that takes in a parameter n that checks if the number is a perfect number. So the return should be either true or false. So those are our Booleans. Use this function to write a Python program that prints out all the perfect numbers from 1 to 1,000. Okay, so let's have a look at that. Okay, so the way that we define a function is using the keyword def, followed by the function name, and then we have open brackets, close brackets, and inside that are any parameters that we want the function to have as inputs. So to define a function, we use the keyword def for define, followed by a function name. And remember, the convention for function names is the same as the convention for variable naming. Okay, followed by a function name and its possible parameters. You may also use arguments. So parameters, arguments, that can be used interchangeably. Okay, so we start off with s being equal to 0. Now, this is not the best coding practice because s doesn't really explain anything. So let's just put a note here. This is not the best naming because we don't know what s is used for right away. Okay, so I just called it s equals 0, but we don't really know what s means. It's just a single letter. We can't really infer any more explanation. On the other hand, if we called it sum or something like that, then we know what that variable is going to be used for. It's going to be used to sum up something. Okay, so sum, that would be a better naming. Then we can call it sum over there. Okay, so just you don't need to follow this advice, but when writing the programs for this course, it would be best to name your variables something that provides a bit more information as to what those variables are used for. Okay, now you don't always have to do that. Maybe it will be obvious just by reading your code later on, but just keep that in mind. Okay, so we have sum is equal to 0. Then we go through we go from 1 to n, because remember, we're starting with 1 as a possible factor, and we go up to n. Now, remember back when we did the factors of a number, we had to go up to n plus 1 because we wanted to include the number itself. Here, we go up to n because we don't want to include the number. So here, n is not included in the for loop. So the for loop will stop at n minus 1 because this bound here is not included. Yeah. So we can imagine this as interval including 1, not including n. Okay, going up in ones. Okay, and then this is very similar to what we had before, checking if it's a factor. If I divides n, then I is a factor. Since it's a factor, we add it to the sum. Okay, now that we've got the sum, how do we know if it's perfect or not? How do we know if the number is perfect? The number is equal to its sum. So here we check to see if the number is equal to its sum. So here, n equals sum. This is checking for equality. If this equality is satisfied, then this returns true. If it's not satisfied, it returns false, which is exactly what we wanted this function to do. Okay, so this function can then be used to check if a number is perfect or not. Okay, then the question asked to check in the range from 1 to 1,000 for perfect numbers. So we do that here. We start off the range with 1 because we don't want to include 0. So we start the range with 1. Remember, the default starts from 0. So if you don't want to start from 0, you need to change the default behavior. So the default behavior is starting from 0, because in computer science, we start counting from 0. Then the upper bound is 1,000 plus 1, because again, the upper bound is not included, so we need to add this extra 1 so that the 1,000 is included. So we use 1,000 plus 1 so that 1,000 is included in the range. Okay, so later on, we'll see that this is very important. If we want to include things or exclude things from the upper bound, we may or may not have to add this plus 1. Okay, but we will see that later on. Then we can have our print statement. So we print n, comma, remember the comma just leaves a space, and then perfect of n. And then this will be either true or false, depending if the number is perfect or not. Okay, so you can run this for yourself. The code is available on the course webpage. And if you go through the list, you'll see that the only perfect numbers are 6, 28, and 496. Okay, within this range. So we have 3 perfect numbers in that range. Okay, any questions on this one? Okay, cool. I think that was it for the medium questions. Okay, so for the difficult questions, I'll just go through it quickly. The code is pretty self-explanatory. Okay, so 3.1, write a Python program that asks the user for coefficients a, b, c of a quadratic polynomial. So that's something like ax squared plus bx plus c. Now, we know that from the coefficients, we can determine the possible roots of the polynomial. Okay, remember your quadratic formula. Okay, so we want the program to output the roots of the polynomial. And we know that there are three different cases. So we can have two real roots, we can have a single root, and we can have two complex roots. So what we want to do is output the root or roots and then the category. So two real, single real, or complex. Okay, so let's have a look at that. Okay, so first, I've imported numpy as np. Remember, if we use this as np, this just gives an alias to the module. So this np is an alias for the module name. So instead of writing numpy all the time, we can just write np. Okay, so first we need to get A, B, and C. So we have input A, input B, input C. And remember, whenever we're working with the input function and we want something else that's not a string, we need to do the typecasting. Okay, so here we've typecasted to a float because the coefficient may be an integer, maybe a fraction. Let's just put it as a float just to be safe. Yeah. Then we calculate the discriminant. So remember that is the triangle or the capital delta, and that's b squared minus 4ac. So this, let's put here, calculate the discriminant to check the nature of the roots. Yes, I think you did that in Math 130, the nature of the roots. Yeah, and we know that there are three cases for this delta. If delta is greater than 0, or if the discriminant is greater than 0, we know that there are two real roots. And we can determine the roots x1 and x2 just by using the quadratic formula. So minus b, 1 plus, 1 minus, and then the square roots of the discriminant, all divided by 2a. And here you can see I put brackets around everything just to make it perfectly clear which operations are done first. So if we go here, we remove these brackets, we've got here divided by 2 times a. So that might be a bit unclear. Are we dividing by 2 first and then timesing by a, or are we dividing by 2a? Okay, you can clarify that by looking up the order of operations, or we could just put brackets and say, do that first and then do the division. Okay, so just if you're ever in doubt, always put the brackets. So ever in doubt, put brackets to say explicitly what needs to get done when. Okay, so here we were saying do the 2a, do this minus b plus the square root, and then do the division. Okay, so it's very clear what's happening there. And then we can just print out the roots. Now, if delta is less than 0, that means we're dealing with complex numbers. So we can separate the complex number into two parts. We can have the real part, which is just minus b over 2a. It's the real part. The part that makes it complex is that this delta is negative. So the imaginary part will be square root of minus delta divided by 2a. So we need to include the minus delta, because delta is less than 0. So that minus 1 that appears in the delta, we're going to take that out, and that becomes the imaginary unit I over here. So the first complex number will be the real part. So here I've turned it into a string using the string typecasting. Then I've used string concatenation to add the two strings, to add these 1, 2, 3, 4 strings together to make one string. So we've got the real part plus I plus, and then we have in brackets the imaginary part. So we can think of this as one string, something like Z is equal to A, the real part, plus I, imaginary unit, and then B. Okay, so it just formats it nicely into the complex form a plus rb. Okay, and then we do the same thing with the second one. Sorry, that should be a minus. Okay, so we got the plus and the minus. So those are the two complex solutions. And then finally, in the else statement, if it's not greater than 0, it's not less than 0, then it must be equal to 0. And if delta is equal to 0, then we have one root. And we know that it will be minus b over 2a because the square root term vanishes. Okay, so here we can use the if statements to break up the flow of the program. So if it's two real roots, we do this first part. If it is two complex roots, we do the second part. And if it's one root, we do this last part over here. Okay, any issues with this one? Okay, cool. Okay, last question here, 3.2. Write a Python program to test whether a given comma-separated sequence is arithmetic or quadratic. Okay, so that goes back to your high school sequences. You can have an arithmetic sequence or a quadratic. The program should output either arithmetic or quadratic. So we need to determine which one it is. The program should determine A and B for the arithmetic sequence. So remember, arithmetic is an plus b. And for quadratic, we need to determine a, b, and c, where it's an squared plus bn plus c. And here I used the double star for exponentiation. Okay, so let's have a look at this program. Okay, so the first thing that we need to do is input the sequence from the user. So here I have seq just as shorthand for sequence, and then str just because it's a string. Okay, so that is inputted from the user. Then, like we had before with the comma-separated values, we use list comprehension to first split the string up on the comma. So that will give us the individual substrings. However, S is a string. We would like a sequence of floats, so we typecast it to a float. Okay, of course, you could typecast to an integer, but maybe the sequence has fractions in it, so rather be safe and typecast to a float. Okay, so how do we determine if it is an arithmetic sequence or a quadratic sequence? Well, if it's an arithmetic sequence, it's going to have a common first difference. So let's check that. So first difference 1, that's going to be the second element in the sequence minus the first. Remember, we start counting from 0. So S1 is the second term, S0 is the first term. So let's just make a note there. S1 is the second term. S0 is the first term. So that is the first difference between the first two terms. We can find the first difference between the second two terms. If those are equal, then it's going to be arithmetic. So A is the first term. That's just high school work. And then B, remember how we determine that? We substitute the first term, and then we can solve for B. So just as a note, Tn is equal to An plus B. If we substitute 1, we have A plus B. We take that across to the other side, and we can solve for B. Okay, so we have A and B, and we can print out the little string here where we have concatenated each part. Okay, and that needs to be concatenated as well. So Tn is equal to the string formatted form of A plus N plus the plus character, and then plus B. Okay, so then this will give us our Tn equals An plus B over there. Okay, so there are better ways to do the string formatting, but we will look at that later on. Okay, so if it's not arithmetic, it must be quadratic. And how do we determine that? Well, we go back to our high school work. So remember, we use the differences. So if we just go here, sorry, just as an example, if we have T1, T2, T3, T4, and so on, we find the first difference. So that will be T2 minus T1. Then we have T3 minus T2. And then we have T4 minus T3. We call that the first difference. Then we find the second difference. So that's going to be the second term here minus the first term here, and so on. Then we know that let's make a space here. So this is going to be 3a will be, 2a will be this last bit. 3a plus b will be this term here. And then a plus b plus c will be this term here. Okay, so that's back to your high school work. So we've got 3 equations, 3 unknowns. We can use that to solve for a, b, and c. So I just said x was this first term, t1. Y, that's the first difference. Z was the second difference. And then we can just reverse these equations to find a, b, and c. Then once we have a, b, and c, we can just format a nice string here. For tn is our a, n squared, plus b, n, and then plus our constant term, c. And like I said, there is a better way to do the string formatting, but we will have a look at that later on. Okay, it's not so important. The main part is getting the maths operations correct. Okay, the formatting and the output like that is not so important. Okay, any questions on this? Okay, cool. Yeah, so that's it for the tutorial. It should just give you a quick review of how to use Python to solve some simple problems. If you do need a bit more revision, there are 25 extra Python questions in the notes. Okay, so at the end of the first chapter, there's some questions there. Okay, so just a quick announcement on the remaining lectures for this week. So they will be online. Okay, so I know you had the clash, so that's fine. You can watch the videos later. But those lectures will just be going over those exercises. Okay, from the back of the first chapter. Okay, so for tomorrow and Friday, we're just going to be going through those exercises. And then next week, we are going to be starting with revision on vectors and matrices, and then going into vector spaces. Okay, so that will be new. Okay, any questions on the plan? Okay, so the semester plan is also available on the course webpage. So we will be following that. Okay, cool. If you do have any questions, you can always email me. And my office hours are pretty much most of the day. You can just come by and ask your questions. Okay, will there be recorded lectures for the rest of the semester? Yes, there will be recorded lectures. However, it won't be on everything. So the Monday double, that will be pre-recorded, and it will be an introduction on what we're going to be covering for the week. And then the remaining lectures will be in person. Okay, but we're just checking on the registration numbers. If there's not so many people, then we can have everything online. Okay. However, that might change. Okay, so for now, the Monday double will be recorded and everything else will be in person. Okay, but I will I'll update you if anything changes. Okay. Okay, cool. So if you do need help with those Python exercises, those videos will be uploaded tomorrow and Friday, and then you can go through those. Okay, so I'll see you next time.